okay? Good. It's so bright. Okay, it looks like that's good. So today, I'm gonna try to use the projects more. The GitHub projects, just so other people could see it, and I think it's better than my... I don't know, I kind of like keeping track of the tasks in these little daily notes, because this is very easy to do, and I kind of hate when your task management becomes kind of a chore on its own. And you can see here I have other things, and like with task management, what happens is these things would get added into the to-dos, and I wouldn't have any way to just be like ignoring all this, like you have to move them to an arc, like a backlog or something. So I don't know, we'll see how this goes. I'm not sure. I guess the Friday can get closed. So what I was doing is basically every day I just copy and paste the previous one, and then I make some new ones, check off the ones I did. And then I can just use my judgment every day of like, oh, maybe I should go back and look at this or not. But here, when you kind of create them all, you should do them in a backlog first. And then like the immediate ones you're going to do should go into to-dos, I think, and then the other ones go into in progress. But yeah, so the goal today, we have a bunch of auth code from yesterday. I got to take a look at all this Elixir code. I'm not particularly strong in the Elixir code. I've like used Phoenix a couple times, but all with the LLMs, and so I need to get better familiar with the syntax here and what's happening, because I'm going to be looking at a lot of this code. Ideally, the Elixir server is going to be pretty simple with end-to-end encryption, and most of the logic's actually going to live on the front end. But there's just some core pieces here that are super important, like how login works, and how vaults work. So when you log in, you get access to your user vault. Your user vault it points to all your group vaults, and then your group vaults have your current keys for accessing the groups. And then there's a second sort of login thing, which would let you get access to all your all the group's historical keys for whatever time period you were in the group. So all of that needs to be pretty secure, or just, it needs to not have like super obvious broken thing. So got to take a look at all this code. This is the basic login stuff. It's probably fine. For the most part, it's using the Phoenix library. Or Phoenix, it's using something for auth. Like, it didn't build the auth itself, but you know, I gotta check what's going on here. It's kind of annoying because like if it were Python or TypeScript, I could just know if there's anything completely wrong. Here, I just like might not even notice because I'm not familiar with the syntax. And then, yeah, when you look at this code that you're not super familiar with, my sense is it's just really hard to like think through all the steps. You just kind of like look at each piece and say like, is this okay? Basically the same thing that the models do themselves. So they just like look at each thing individually. What you really want to do is like think about, you know, is this a good structure? No, pup, you don't need your toy right now. Okay, I'll get her a toy. I folded in 2 seconds. It's her toy. All right. So I don't know how I'm gonna do that, but I gotta look at this code. At least have some sense of what's going on here. I can't just check this stuff in without having any idea what's going on. So that's what we'll do initially. Better turn the brightness up on my screen. The sunny January 31st. Yeah, pixel brightness is too low. Turn it up. Go. I can see. Audio's good. So, yeah, I didn't talk about either here. So we basically have login now. not on the public website. It's not running right now. Let's start it. Start up the dev server. Okay, dev server is running. I'm already logged in. Gotta log out. So we have login. It checks if it's available. Make sure you have a password. You can do 32 characters. But it has to have 2 digits. At least 2 digits. Log in. Then you're logged in and you have an auth token that you can use for the WebSockets, or you can use it for the GraphQL requests. So here we're using GraphQL instead of having any APIs. It's a little bit weird here. Most of these are very simple APIs, but my plan is eventually to do a public, to have public groups. And for those public groups, it's going to be basically an entirely different flow. And so GraphQL sets me up nicely for that. And my experience has been always do stuff early with the LLMs. Always do stuff early because it's a pain to get them to migrate stuff. Because it's so much code and you're burning through so many tokens and they make mistakes, and you just want to set up what you want up front. Even if it costs you a little bit, it's worth it. Because even with GraphQL, you're going to want to like evolve your schema a bit and kind of think about things. And so if you don't do it up front and then try to have it migrate, you're going to like have kind of a shitty implementation, and then you have so much stuff already, and then all that stuff has to kind of migrate. And like you're doing multiple migrations as you kind of try to get stuff working well. Why is this getting logged? Debug log. Oh. Just telling you. You got an intersecting query. Okay, how am I gonna do this? So we have login and log out. I'm going to first take a look at this just so I know basic syntax. Although Elixir itself, I've looked at this before, and Elixir itself doesn't have much syntax. So that'll make it a little bit challenging. That's the thing, like the thing with Elixir here is there's so many little details to understand about what's happening to really have a good sense. They're just not how you would maybe do stuff in other languages. So these are constants basically. I forget what the name is for that. What they're tuples? Or no, tuples. Atoms. Elixir is a modern functional language built on top of the Erlang VM. It's fully compatible with Erlang, but features a more standard syntax and many features. Actually, let me just start. No one's watching, but if someone ever does, if I ever do. The reason to use Elixir versus say Python or TypeScript, or even Go. So let's see. I'm trying to think of where to begin. Python and TypeScript are both single-threaded, which most people know. Python's a little bit more extremely single-threaded with its global interpreter lock. But basically that means that they don't have shared memory structures that you can use. And so everything you do, like when you create variables and stuff like that, none of that deals with any shared memory. It makes it very easy to program because you don't have to think about shared memory. Then as long as your stuff is stupidly parallel, you just spin up more Python processes or more node threads, and you're fine. You just scale. You scale perfectly linearly with the amount of compute you have. And so that's fine. Let's see. Let me open up trying to think. I'm just trying to think because it's going to take me a long time to type. I could use text to speech, but I don't really need that. I want to do bullet points of what I'm saying. So let's say, why not TS or Python? So both are single threaded. This is fine. So long as your work is stupidly parallel, which most web server work is. You get some requests, and they're completely independent of each other. But now, not wait. So you could, which is I think what PHP used to do, is spin up a process for every single request that comes in. So you could spin up a process or a separate thread for every request that comes in. The reason you don't do this is because it's very expensive. Like you have cache connections to your database. Those would have to be every single time you'd have to establish a new connection to your database. You can do this. It actually works fine for quite a while. But as soon as you start to have a lot of traffic, you're just imposing such a high cost on every request, and so then you're incentivized to not do a lot of requests. You can actually take, I mean, that's a totally viable approach. Is to just be like, we're going to request stuff less, we're going to have, you know, bigger requests. Maybe you do something like GraphQL. GraphQL is designed to do small requests, but you could do huge requests. You can structure your whole front end around that, but you're going to basically be contorting yourself on that position of, you know, not worrying about it. So then in Python and JavaScript world, what you do instead of spinning up a process or a thread on every request is you keep the threads alive. In most cases in Python, JavaScript, you keep the threads, processes alive, so you don't have to re-establish upstream connections, stream cache, connections, etc. Keep some caches. Etc. Yeah. So that's the first step. And that works okay. But still you're basically limiting a single process. This works okay. But you're still limiting a single process thread to handling one incoming request at a time. The trouble with this is that the thread or process is going to be 99% idle while it waits for the DB to come back with a response. Since the slowest thing in the entirety of your app is going to be database requests. It's just reading from disk is slow, period. There's no other way around it. Maybe it's waiting for a different API from, it's also got to read from a database, but at the end of the day, your slow link is going to be reading from disk. That's why you cache stuff. It's just, that's going to be a problem. So the point is that your thread or your process, it's still a huge amount of bloat because most of the time it's doing nothing. It can't accept any other requests at the same time. Like this, assuming that you're doing it in these stages I'm saying, where you keep the processes or threads alive, you don't spin up a new one every time. This already introduces some risk though, that a previous request could leave that process or thread in a messed up, in a bad state. So you could spin up a process or thread for every request that comes in, right? That's nice. They're completely independent. If something weird happens within a thread because of a user's state, it can't affect any of the other users because you're spinning up a new one. But spinning it up, the thread or process, is not a cheap thing to do. So instead, you just keep them alive. And now you route a request through each one. Well, what happens if some user leaves like the local cache in a bad state, or they like mess up the database connection for some reason? Just different things can happen. Maybe there's some bad code path that they hit. Well, now that thread or process can be messed up, but you're reusing it across different requests, right? And so you can already have some risk because of that. But it's not a huge risk. Like, it can happen. It's fine. It's not a big problem. This kind of risk is not, these are not things that happen super often, where like one request comes in, messes up the state, and then the next request comes in and like is messed up because of the previous request. It does happen. It's not the number one issue. And the reason is because I said this setup works okay, but a single process or thread is still super heavy to keep alive, because it's going to need its own database connection, right? Like, so every single one of these needs a database connection. Well, you're going to need a bunch of these threads or processes to handle the amount of incoming traffic you have. Otherwise, your machine's going to be very busy. And so each one of these is using a ton of memory. And that's ultimately what would be your limit, is you can't spin up 10,000 Python processes on your server unless you have, 500 gigs of memory. I don't know what the numbers are, but my point is, maybe it's like, for JavaScript, you have to have V8, right? And V8's pretty big, which is why like Electron apps use multiple 100 megabytes of memory. The same thing's kind of true for Node. You're going to be using 100 megabytes or so at least to run Node, whereas something that doesn't have something that's compiled like Go might use closer to a few megabytes or less. So yeah, you have 100 megabytes, right? You want to spin up 10 node threads or processes. You're going to be in the, gigabyte range. You want to spin up 100, you're going to be 10 gigabytes ish. So yeah, this does not allow you to scale. You get limited by the amount of RAM you can have, and you have CPU, and you end up interrupting the CPU every single time one of these threads or processes needs time to work, because they're not coordinated in any meaningful way. And so the CPU essentially has to coordinate them, because like, let's say you have 10,000 processes and they're all waiting on the some of them are waiting on the database, some of them are getting an incoming request. They're all going to be vying for CPU time, because the CPU can only do so many things at once. So it has to schedule when those processes or threads run. It's very expensive. So the second step is, instead of doing this, you start to use async primitives. So first step would be keeping threads alive across requests. Handling multiple concurrently. That's step 2. So for this to work, basically what this is that you have all these processes, right? You want to handle, in step 1, you want to handle 1,000 requests at the same time on your server. You're going to need 1,000 processes or threads in Node's case. So you're going to need 1,000. Give me the toy. And you're like, all my processes, they're sitting idle 99% of the time. Why do I need 1,000 processes? Why can't I have like 30 or something, 10, whatever it is. So to do that, you need to basically have each process or thread handle multiple requests at the same time, so that those threads or processes can be busy more of the time. And so this is generally what we call async or concurrency or things like that. These things are used in a lot of ways to mean a lot of things. But this is the main idea. So now let's design our processes so they can handle multiple requests at the same time. To do this, we set up something like callbacks, interrupts, so that within our process, we can say when we want to release control back to our own scheduler. I don't know, that interrupts is maybe further down. So with async, you have something like an event loop where the process keeps checking if there's any work to do. In your code, this is, let me think how the best ways to describe this. You have an event loop, you define like async functions. This is how most of them work today. They don't have to work this way, but this is just one of the ways they work, which applies to a lot of the languages like Node and Python, and some of the other ones too. This is what's called cooperative multitasking, which is, you don't necessarily need cooperative multitasking to do what I'm saying here, which is to have a single process handle multiple requests at the same time. You could do this with, there's cooperative and there's I don't remember what the alt. Man, I am not on the ball when I get started. My brain is just still getting warmed up. Preemptive is the name for the alternative. You have cooperative and preemptive multitasking. Preemptive is basically where the scheduler says you're done running. I'm going to schedule something else. Most of the systems use cooperative multitasking because preemptive multitasking usually costs you something. The CPU uses preemptive multitasking. It'll just tell your process, your time's up, you know, I got to schedule other stuff. And then it has to have a context switch where it swaps the stack onto this from whatever process is running to the other process. So the reason kind of most software is set up with cooperative multitasking is because the entire reason you're doing that is because the CPU's preemptive multitasking is not very effective. I mean, it's effective. It's just it's for a specific thing. So in your own program, you kind of know like, hey, I'm waiting on a database request. You can do other work, right? And so you'll await a database request, which tells the scheduler, oh, there's nothing. I can schedule some other work now. The scheduler within the process. I just like, no. If someone didn't understand these things and they were listening, it would be so hard to follow. It would take me, like, I would need someone asking questions, and then I need to lay out the entire surface and then bring it all back in. Fuck it. Just keep going. In your code, you know when you're not doing work. You wait there. Wait there, and this schedule. Schedule's over. So this lets you drastically reduce the number of processes because you can probably handle something like 10 to 30 requests concurrently in I think the number might be a little bit lower. 10 to 30 might be a little bit high. Let's say 5 to 20. And then this will give you something like 50% utilization of that process instead of, I don't know, 2 or 5 or whatever the number is, 2%. You don't want to be at 100 because if you're at 100, it means all your requests are going to have added latency. You don't want to get to 100% utilization of the process thread because then all the events, tasks, are going to be waiting on each other, which means you're increasing latency for the user. So like when you're at 2% of utilization on a Python process or thread, node thread, you have a ton of extra time. Basically, there's no perceivable cost to the user to schedule more stuff on that thread or process. So when you go from 2% to 20%, none of the users notice any different because the CPU is still idle almost all of the time. But you start to get past 50%, and now, you know, person A's request is ready, like the database has come back, but the CPU is still scheduling, like still doing stuff for one of the other requests that have come in, and you're getting put behind the line, and now your latency is starting to increase because of that. And so that's kind of what you try to avoid. So you essentially don't want to, can't fully utilize CPU this way. So you overschedule the number of processes But this essentially, but this also is the same thing. So if you overschedule the number, you'll do like 2n plus 1 processes. You could do 4n plus 1 processes. The more processes you schedule to try to increase the load on your CPU, the CPU has the exact same issue, right? Which is that if you're getting the CPU to 80% total utilization, you're going to have problems with context switching and stuff, which is going to increase your latency as well. So you have to be conscious of both of these things. And effectively, what this means is you can't fully utilize your CPU without incurring pretty high latency costs. And you're kind of mixing two different primitives, concurrent cooperative multitasking, and then the CPU's preemptive multitasking, and trying to balance across these two things. And they're completely unaware of each other for the most part. So they can't coordinate very well. And you have no real understanding of what's going to happen when for your program and how to account for that. So what you end up doing is you end up just running these kind of things at relatively low CPU utilization, so that your server will at max be 50% utilization, which is fine. Sometimes, I mean, it gives you some capacity, but things start to degrade very quickly. So it's kind of like fake. It's not like you really have double the capacity. It's like you have 10-20% more capacity. You start to get beyond that, and the service degrades for everyone. So yeah, but this is sort of the second step, right? Which is, and then now you also have a lot more risks that a concurrent request messes something up, like your TV connections or anything. So now you could imagine incoming user requests, some amount of them like holding open database connections, and any new request coming into that process doesn't have access to database connections because they've all been used up by the other processes that are doing something wrong. Like it could be specific to the user or whatever it is. So, yeah, you're starting to take on a lot more risk. They could be blocking the event loop by doing synchronous tasks, CPU work, reading from disk, sync, or math sync. Yeah, so like if you use NumPy, right? Like, and you use NumPy within the request, and now other requests come in, they're all blocked until that can happen. They can't even start working, or if like the database comes back, they can't finish their work. And so now you have a lot more risk, because all of it's cooperative. So if all of the work and this type of setup is cooperative, so if any of the concurrent requests on that process don't release their lock on the event loop, it's not really a lock, they're just doing work, but event loop, then nothing else can run. It's more like usually they're going to release, but so third step. So now you're like, also, we still can't share a lot of stuff, like DB connections across our processes. So each process needs its own small pool connections. which increases load across our systems. You can get around this by pooling outside. Feature bouncer. There's other stuff. Feature bouncer. Envoy, something like this. The third step. Now you're like, you know, I want to be able to Golang. You want to be able to share your connections across your workers, threads. So now you create a single scheduler across all of them. So in Golang's case, you create a single scheduler, you have threads. All the work comes in. All the requests come in, and the main scheduler picks them up and starts queuing. And in Go's case, and the worker threads pick up work to be done off of queue. I don't remember the exact details. It's something like this. Like, I don't know if the main scheduler picks up. The main there's like a main scheduler that just watches the other ones. Each one's its own like independent scheduler. It has its own event loop, which has like, do I have work? If I don't have work, go pick it up from one of the other workers. But I'm pretty sure there's a single thread that handles all the incoming requests. Don't want to say anything that's necessarily wrong, really. So I'm just going to talk about the advantage here is that you can more effectively get to 100% utilization of the CPU, because issues with specific get shared across all of your worker threads. So if some request keeps a worker busy. So some request keeps a worker a thread, but I'm gonna give her a truth. So if some request keeps a worker or a thread busy, one of the other threads can just take up the... You can save resources by sharing your stream. The biggest issue is that the way Go does this, it uses channels, blocks, shared memory. This means that the more concurrency you use, the more risk you take that you end up something like a deadlock. Also, mechanics in your program affect the entire process, and you have to try to use them. So yeah, Go has advantages. It lets you get closer to 100% CPU utilization. I think you also only need a single garbage collector and stuff. Other things, you know, it's compiled and it's a different thing. Those are all separate sort of from the concurrency stuff. Other than, you know, you can schedule more stuff because you're using less resources. But these are the big issues with Go. The more you use the concurrency primitives, channels, whatever it is, the more likely you are to have deadlocks and panics, right? The more work you do within your Go service, the more your Go service can fail, which is not the behavior you want. So I think the fourth step is Erlang and Beam. These trade performance. So you don't use shared memory primitives like Go, where you have to get locks on the shared memory to make changes. Instead of sharing memory, Go, all memory is immutable. So now you have no risk of deadlocks at the trade-off. It being less performant. Copying big structures is expensive. Copying big structures is expensive. Period. The other thing is that Beam isolates all workers, have their own stack heap garbage collection. This is also less efficient. The trade-off is that you can't have a single worker take up all the heap stack, the entire server. What this means is that you can build very large applications without having to worry about one thing taking down your entire server easily. And this is especially useful when you have a lot of developers within a single service, and they're very incentivized to get stuff done quickly. And so it becomes obvious why this is also important working with LMs. So, you know, this is already a useful thing in my opinion. I think even for yourself, it's a useful thing. Generally, developers trust themselves, and so when they're building out their service or whatever, they think they don't need these sort of safeties. I don't feel that way because I know if the application gets big enough, I won't remember what happened. I don't know that I won't make a mistake. But I find a lot of developers think like, oh, of course, I mean, I'm not going to make a mistake and I'll just put stuff in place so other people can't make mistakes either. But it's clear that even with just working with other developers, you should understand that you can run into these things and that the trade-offs here are very valuable. And then if you're talking about LLMs, you definitely don't trust them as much because they're even more liable to not consider the entire code base or things like that. And you can do a lot of work to try to avoid issues with these different setups. So like with a single event loops like Python and JavaScript, what you can do is you can just see how often the event loop's locked. So you can put in an interval every 10 milliseconds or something and make sure that it ran after, within 12 milliseconds. And if your interval didn't run within 12 milliseconds, the event loop was blocked for longer than 2 milliseconds at least. And so, yeah, there are things you can do to check for those things, but now you're retroactively trying to fix them. There's nothing you can really do preemptively. You can kind of set up canary processes and stuff like that. The point with Erlang and Beam is you don't have to worry about any of that. Like, if something's messing stuff up, there are ways their actor model can have issues, just like anything can. But like you can get ever increasing mailboxes and things like that. But you're going to have problems with any of the different stuff. The point here is that the kind of easy failure modes really go away. And that was the entire premise behind all this. So that's why, I like Elixir. It lets you, I like Beam specifically. Elixir I'm more neutral on, but it's the one to use today. Yeah. The way you can kind of deal with some of this issue of immutable memory being very expensive to make changes to data structures. If the data structures are very large, for example, Discord had issues with large groups adding and removing members. You can use Rust. Elixir at least has good Rust FFI, foreign function interface setup. It's easy to use. So you can modify the structure with Rust, and then you're just kind of, you're one-off making these choices that you want to not copy memory, which I think is the better thing to do when you know you need it. So that's that. Back to Elixir. Elixir is a modern functional language built on top of the Erlang VMs. It's compatible with Erlang. Comments, don't care. Integers. Odd. Elixir supports multiple integer bases. 0x is hexadecimal. I see, so the hex, 1f is the hex. 1f. Let me think about that. So 16. Yeah, 16 plus 15, 31. And 2f would be 47. You can do binary with a b. This would be 2, 6, 14, 16, 31. Yep. 16 plus 8 plus 4 plus 2 plus 1. Octal. Octal. When would you need to do octal? I guess for binary. I mean for 8-bit versus bytes. Yeah, makes sense. This number has to be bigger. It's less. Decimal. Good. No. Hex. Binary with a B. Atoms are constant whose values are their own name. They start with colon hello. Constants whose value are their own name. Constants whose value are their own name. Yep. Tuples that are stored contiguously in memory. Tuple. We can access the tuple element with the element. Yeah, so one thing is like even after you read all of Elixir, there's a separate thing, which is Phoenix, which is the framework, which is a lot of the functions and stuff that you're using that just exist because of Phoenix. I wonder if they have Phoenix. They don't. Tuples. We can access each element of a tuple with the element function. The first element of the tuple. Lists that are implemented is linked lists. List. Tuple list. We can access the head and tail of a list as follows. Tired. You should not be tired. Access the head and tail of a list as follows. That's pretty cool. So you can destructure the head and the tail. In Elixir, just like in Erlang, the equal denotes pattern matching and not an assignment. Means that the left-hand side is matched against your right-hand side. Pattern match will error when the sides don't match. In this example, the tuples have different sizes. Let's check. So if we do head equals 1, 2, 3. Yep, you can't match. So if we do head, tail, head, tail. Yep. Can we reassign? I'm pretty sure we can. Yep. Yep. But then it doesn't have, this is just a variable name. H. Yep. Yeah, this isn't some special keyword or anything. This sort of type operator. Just, we'll take the first element. So I wonder if I can do H, E. Nope. H comma, I see. Yeah, that's H, E. Now I have H, I have E. Yeah. Yep. Cool. In Elixir, just like in okay. This is how the above example. The pattern match will error when the sides don't match. In this example, the tuples have different sizes. A, B, C equals 1, 2. Do that. I wonder if we can do this. A, B, C equals 1, 2, 5. Yeah, so we can't use it with maps, with tuples. Can also be used update maps and structs. Map e value. Okay. We can't. Oh, that's not what I want. Fuck. There are also binaries. An Elixir, a binary is a sequence of bytes. And Elixir strings are actually binaries. Let's see. True. Cool. What happens if we do this? Oh. Can't do this either. C, D, E, A, H. Equals 104. You can specify how many bits each element uses. What? One is 8 bits. So how is that 18? 56? Working with text, you can mix bytes and text. Hello, 0. Yeah, so when you do the string, it just flattens it. Yeah. But it looks like it'll represent it in the interpreter to you. Oh no. No, this is wrong. It'll represent it as the beats. What I didn't understand was this. Give her a bath. I probably should have done that before I started streaming. It's nice and sunny today. And dry off. Let me break down the operations a bit. Okay, 1 as 8-bit, 2 as 16-bit, 3 as 8 bits. You can't name them all together as binary. me see. $156. So each one of these is a byte. Values. This is 0, 0, 1. I see. So what happens if I do, okay, if you do 1, 4, and 2, 4, it just makes them a single thing. And this becomes 18. Good. Strings and characterless. Huh. Use single quoted strings to represent character lists is deprecated. That's a good idea. Otherwise, it's really not clear that's what you would be doing. Why would you? What it is. I do this. Okay. Just depends if you want a list or if you want to. What is this called? Binaries. Sequence. Some Erlang libraries only accept character. If you need to maintain characters as a list, character will give you that. I'm so tired. Like, I'm not that tired, but I'm just... It's just I could take a nap right now. Annoying me. When you need list operations, if you need to manipulate characters as a list, let's give you that directly. List. Yep. Add them to list. We rarely use character lists for new code. Strings are preferred for most tasks. Character lists mainly exist for Erlang ability. We're just building Elixir applications and not calling Erlang functions that require character lists. We'll almost always use a string. Multi-line strings. Strings are all included in neat. Strings are really just binaries. Character lists are just lists. Question mark A and Elixir returns the ASCII integer. Oh. Concatenate lists, use ++ for binaries. Have lists, concatenate them. Same thing with strings, or character lists. For strings, I gotta use that. Ranges are represented as start to end. I think after I finish this, I'll go give her a bath break. Come back and take a look at this code. Ranges are represented as start to end, lower, upper. Maps are key value pairs. Maps with atom key. Maps with if you if you don't want to have to use a string, let's see this. Vendors. What is it? The math. 1 + 1 is 2. Live. Like the operate. Flash always returns. Your interdivision you give. We get the division remainder. There are also Boolean operators or not. Boolean on the left hand side. Elixir also provides or and not, which is the argument. All values except false. All values except. How do you convert? Looks like it's already spring. And it's January 31st. Triple equals are more strict. Pairing floats and integers. Elixir operators are strict in their arguments, with the exception of comparison operators work across data type. They're strict in their arguments, with the exception of comparison operators that work. Elixir, every type has a defined position. Numbers come. Allows you to compare and sort heterogeneous data structures. Cool. This enables building collection types. While there is an overall order of all data types, the actual order is not important, but that a total ordering is well defined is important. If false, do this. Any control flow structures Elixir rely on pattern matching. Case allows us to compare a value again. Oh. Case 1, 2, 2. One, two. Let's comment to bind the value to if we don't need it. Yep. use underscore. For better readability, we can do the following. Condition lets us check for many conditions at the same time. Use condition instead of nesting many if expressions. I won't be run either, but I will. Does comment set the last condition equal to true, which will always match it. This is just a switch. Pattern matching, and then we have a switch. It doesn't say what happens if 2 are true. Yeah, it only does one of them. It actually, could I do this? Yep. So you can assign the results. What happens if I do this? So you can't assign within the switch? Try catch is used to catch values that are thrown. It also supports an after clause that is invoked whether or not a value is caught. Also supports an after clause. Anonymous functions. Square is a function. They also accept many clauses and guards. F is equal to function when x is greater than 0, x plus y, y is x, y times y. When x is Elixir also provides many built-in functions. And group several functions into a module inside of a module. Use def to find your function. private functions with defined function defined with def is available to be invoked from other modules. A private function can only be invoked locally. Function declarations can also support guards and multiple. When a function with multiple clauses is called, the first function that satisfies the clause will be invoked. Invoking area, circle 3. Okay, function declarations also support guards and multiple clauses. Function with multiple clauses is called the first function that satisfies the clause being invoked. Looking area, circle. Due to immutability, recursion is a big part of Elixir. Define module recursion. Do sum list head tail accumulator. Do sum list tail accumulator plus. Define sum list empty array accumulator do and. Yeah, what happens if you try to do, I see, head, tail, equals that? Doesn't work. Tail is empty. Recursion. You probably have to return the call. Elixir modules support attributes. Ones. Module doc. Compute on an example module. My data. Grid this. That's it. Module attributes in Elixir for compile time call. Store constant values to use the module. Find module config. Max reach 5 API. Well, connect. Store settings are metadata. Declare this module, implement server. I'm out there. 1000. Required field. Conditionally compile code. Use compile. Checking it. Attributes are evaluated at compile time, not runtime. So you can't use values that are baked into the module when it compiles, making them useful configuration. Yeah, so they're static. The pipe operator allows you to pass the output of an expression as the first parameter into a function. Range. Type it to map. We define a map which creates a new function, and the range gets passed in. And map will iterate over the range value, and then it'll filter each value remainder to divide by 2. It'll filter out only even numbers. This creates a function, this creates a function, which will both iterate over a list. I think we could do something like this. Not compile code. Maybe like this. Nope. This usually on an app requires two arguments, an enumerable and a function. Collection? Oh, the first argument is the collection. Interesting. There we go. Okay. That's kind of confusing. So This passes in as the first argument. These aren't higher order functions. This is just putting it in argument. Structs are extensions on top of maps that bring values. Compile time guarantees and polymorph. Structs. What do we need to? I see. This is not a function. Okay. A module. Also a struct. Access the name. Update the value of age. We take this struct. Update the value of age. I won. Nope. So if you want to do that, you have to do person.fetch info age. This is the standard way to access struct fields. You need dynamic access with field name as variable. Access.key. Use it for maps. Doesn't work for structs. Your message actually tells you struct. Do it. Get in, go in, access. Didn't we already have a try catch? Yeah. Try catch is used to catch values that are thrown. Try catch. Try do catch. Try do. Speed of runtime. Try do catch. These are different mechanisms for handling different types of errors. Rescue for exceptions. Rescue catches exceptions. Things raised with raise. Exceptions. Try to raise thrown values. Try to throw catch. Exceptions. Thrown value. Most Elixir code uses rescue for error handling. Catch and throw are less common, mainly used for specific situations. After is useful for cleanup, like closing files or database. All exceptions have a message. Okay. Funny that this is like the biggest part of Elixir and it's not very much left. Elixir relies on the actor model for concurrency. All we need to write concurrent programs in Elixir are these primitives, spawning processes, sending messages, and receiving messages. Elixir relies on the actor model for concurrency. All we need to write concurrent programs in Elixir is through primitives. Spawning, sending, receiving. Start a new process, use the spawn function. The function is function 2 times 2. Let me check this out. F dot. Yep. I don't know. So spawn F. Spawn. Spawn returns a process ID. You can use this process ID to send messages to the process. To do message passing, we use the send operator. For all this to be useful, we need to be able to receive messages. This is achieved with the receive mechanism. The receive do. For all of this to be useful, we need to actually be able to receive messages. The receive do block is used to listen for messages and process them when they are received. Receive do block will only process one receive message. In order to process multiple messages, a function with a receive block must recursively call itself to get into the receive do block. Receive do block is used to listen to messages, and do block will only process one message. In order to receive multiple, it must call it again. So we have geometry, area, receive, You're going to get some arguments. Angle, circle. I'm going to put this to the terminal. It's going to call receive. Oh. This. No. Not what I want. This is okay. New. Node outputs. Waiting on compile the module and create a process that evaluates area loop in this. Send a message. How do I send process? The issue is you need to bind the PID to a variable so you can use it later. Yeah, I understand that. There no way to quit it. Without it being in a variable. Yes, you can call, but you need parentheses. Interesting. Why would you need parentheses? That parentheses Elixir doesn't parse it correctly. All right. Yeah, this is just wrong. Let's do this and switch to Opus. Oh, I can't just change it to Opus for this question. That's annoying. Let me copy in. I forget. Supercharged spreadsheets. There are two issues here. You didn't bind the PID variable. You can't type as a literal. That's what I need. Yeah. So much for haiku being useful. Pretty simple question. All right, so we sent. We could send again. We could send again. I got it. Okay. Which means. So it puts the area. Why don't I see the waiting here in the main process? Does IO puts linked to the calling process. Non-IO process is a compile time versus runtime issue. The IO sits in the module body outside any function. Oh, oops. Send that. Nice. IO.puts is the shared output stream across all processes. The message passing to a process. Pretty cool. Which handles the actual writing to std out. By default, all processes share the same group leader, so their output all goes to place. Chain looks roughly like this. Your process calls io.puts hello. This sends a message to the process's group leader. The group leader writes to std out. This is why IO works seamlessly across spawn processes. They inherit their parent. You can actually see this. The main process, process.info self in the main process. Oops. Group leader, process ID of 71. In the spawn process, has the same group leader. Both will reference the same group leader. This design also means you can redirect IO per process by changing its group leader. Oh. Okay. So you have to receive every single time. And you can just keep calling it. Send process ID circle. Yeah. It's returning yeah, we didn't return anything. The shell is also a process, so you can use self to get the current key. An agent is a process that keeps track of something. Do you pipe values back from the just to the calling process? Sure. That's right. There's no automatic return value from the spawn process. You have to explicitly send a message back, which means the spawn process needs to know the caller's PID. Yep. Sense. So, area loop receive. You want to calculate the area of a rectangle. And then the caller is the last parameter. Self is the key. You pass the caller's PID as part of the message. The spawned process apply. Send caller result. Pattern of send a request then wait for response is so common that OTP formalizes it as GenServer. Is this self? is. No. Spawn geometry area loop. It's just no arguments. On function. Yeah. Okay. We spawn geometry as a separate process. We have its process ID. We can send it, calculate the area of a rectangle, and then send a message back to me. It's so common that OTP formalizes it as GenServer cast or call. Synchronous with a timeout. Under the hood, call is essentially doing what the code above does. Passing self, sending the reply back. I gotcha. If we do this. Spawn it. Then we send. And then we have a message in our inbox already. Yep, which is 6. And if we did this again, it would just hang. We don't have any messages. I don't know how to stop the interpreter. This pattern of send a request and wait for response is so common that OTP formalizes a server cast. Fire and forget. Send. Wait for. What is the purpose of cast versus just using send? Passing self, sending the reply back, and blocking with C. Mechanical level, cast does use send. The benefits are more about structuring. Cast wraps your message in. GenServer's internal receive loop recognizes and routes to your handle cast. This separates your business messages from system level 1. This idiomatic pattern is a wrap cast and use GenServer, find an area, public API callers do GenServer.cast. Kernel callers never see that. Fine, handle cast. Callers just call geometry.area. They don't need to know they're talking to a. Okay, so this spins up a process. I did this. And GenServer.cast io.puts. Get the nice process ID. Self. ID. Just self. Not what I want. that. And then I can do geometry dot area self geometry area function geometry dot area is undefined or private. Callers just call. What do you mean they don't need to know they're talking about process? We see they're talking to a process. You could later swap the implementation to a call. But you have a PID in the argument. Where that claim actually holds up. Here. Start link GenServer. Fast handicap. Now I could self, and then I can do geometry dot area rectangle 3. IO.inspect self. IO.inspect uses the inspect protocol. Nice bonus of returning the value it was given. No. You have to start the GenServer. The cast returned okay without any error because that's what cast always does. It fires and forgets. It doesn't check whether anyone actually received the message. A call would have timed out and given you an error. How would we do call with it? I pasted this in, and I didn't have to restart the link. It's just working already. Twitter, where I already pasted the last one. That's hot code reloading in action. When you define a module, the Beam VM loads the new code, and the already running GenServer process automatically picks it up on its next message. Here's what happens. You started the GenServer earlier with start link. That process was still running, registered in the name geometry. You pasted the new module definition, the Beam, loaded the new code. Next time the process received a message, its internal loop called into the new handle call callbacks. This works because Beam keeps two versions of a module in memory simultaneously, the current and the old. The GenServer's internal receive loop dispatches to your callback via fully qualified module calls, which always resolve to the current version, so the running process seamlessly starts using the new code without restarting. The GenServer's internal receive loop dispatches to your callback via fully qualified module calls. How does it switch over? Does area also switch over? Or just handle call? GenServer's internal receive loop invokes your callbacks using fully qualified calls. This matters if you go back to writing raw processing. Compare. Stays on old code forever. Local call. Picks up new code. External call. The first is a local call, so the process keeps running the old version indefinitely. Second is an external call, so Beam resolves it to the latest module code application. GenServer handles this for you. An agent is a process that keeps track of something. Create an agent with agent.startLink, passing in a function. The initial state of the agent will be whatever that function returns. Agent starts. Agent. Let's see. My agent. The process. Agent.get takes agent.get takes an agent name function that gets passed the current state. Whatever that function returns is what you'll get back. First one. Head. colors, head. Update the agent state the same way. Agents.update my agent colors blue beginning of. All right. Nope, not what I wanted. Did I get rid of it? Nope. That's the basics. Are there any other basics I should know about GenServer? Second argument to start link gets passed in it. Start link. Nil. The second argument to start link gets passed in it. Reset condition. GenServer.startLink module initial count. Name. Define init. Initial count. State is the whole point. That state argument flowing through your callback. GenServer manages state. Each callback returns the possibly updated state. Handle info catches raw messages. Call and cast have their own callback. Plain send messages are messages from things like process.send after land and handle info. Handle info catches raw. Call and cast have their own callbacks. Handle info. Ping state do io.put. Called startlink for a reason. It links the GenServer to the call process, meaning if the GenServer crashes, the caller crashes too. Supervisor starts your GenServer via startlink, and if it crashes, the supervisor knows you can restart it. One for one. Those 4 callbacks cover 90% of usage. Init, handle call, handle cast, handle info. There's also terminate, which gets called on shutdown. Natural next step from here is supervisors and supervision trees. Give me a second. Give me a second, Claude. So what happens if someone doesn't return anything from a handle? Seems like each of these needs to return the states. The GenServer crashes. The internal loop expects specified return tuples and anything else kills them. Handle cast forgot a return. The implicit return value here, the return value outputs, which is okay. GenServer sees that instead of no reply state and dies. What happens next depends on how the process was started. If it was started under a supervisor, the supervision tree starts it. For handle call, it's even worse. The caller is blocked waiting for a reply. When the GenServer crashes, the caller gets an exit error too. It's actually why the return tuples are designed this way. Forcing you to explicitly return state on every callback makes state loss harder to do accidentally. You always have to consciously decide what the next state is. Reply. What happens if you apply a handle cast? I forget which one is which. The cast returned okay. Okay, so if you return reply on a handle cast, it crashes. But the caller never knows. The cast already returned okay immediately, long before the GenServer even processed the message. The crash happens asynchronously in the server process. Caller waits, so server crashes propagate to the caller cast. Caller moves on immediately, so server crashes are silent. Also worth noting why reply can't work here. Handle cast doesn't receive a from argument. Gotcha. What does the caller do if they want async, but they do want to check message late? The most common pattern is task.async. Function, geometry.area. But if you want to stay within the GenServer model, you can do it manually. Send a message with your PID and check your mailbox. Area async. Cast. Receive due. GenServer.cast self. Caller, it sends it to the caller. then the caller can receive it. Essentially rebuilding what call does, but with the blocking deferred. The after clause in receive gives you the time. Task.await the task. Supervisors, super trees. The supervisor process' only job is to watch other processes. Supervisor starts to start link. Init is the state. You define some children, geometry, and then a counter. Each entry in children is a GenServer. Supervisor will start according to the strategy. The 3 strategy. 1 for 1, only restart the child that crashed. The others are fine. 1 for all. If one child crashes, restart them all. Use when children are tightly independent and can't function without each other. Rest for 1. Restart the crash child and all the children started after. Use when later children dependent on the early. Supervisors can supervise other supervisors. That's where trees come in. Application, top supervisor, web supervisor, worker supervisor, router, geometry, counter. Each leaf is a worker process. Each branch is a supervisor. If geometry crashes, worker supervisor restart. If worker supervisor itself crashes, top supervisor. Crash limits prevent infinite restarting loops. By default, a supervisor allows 3 restarts within 5 seconds. Child keeps crashing beyond that. The supervisor itself crashes, which bubbles up to its parent supervisor. This prevents a broken process from burning CPU in a cycle. In practice, you rarely start GenServers manually. Instead, your application has a supervision tree that starts everything at boot. In a Phoenix app or a mixed project with mods set, this happens automatically. Application. This is your tree's root. Use application, start. You have some children, you have your repo, endpoint, geometry, counter. Start link children, 1 for 1. When you run mix run or IEX mix, OTP starts this supervision tree. Every process in your app is supervised from the moment it starts. If anything crashes, it gets restarted with clean state. No manual intervention, no try catch again. If anything crashes, it gets restarted with clean state. Don't write defensive code, just structure your supervision trees so crashes are harmless. Okay. I go over here. Where is my application defined? Application in server. You define the project. Happy group server. Elixir. Warnings as errors. There we go. This is in happy group server / application. Start children, happy group server web, happy group server, imagery. So for a mix / Phoenix solution, do all requests. Each incoming request gets its own process. The endpoint in the supervision tree starts a listener. It accepts connections on a port. When a request arrives, it spawns a new process for that request. Your controller action, the view rendering, and the response all happen inside the short process, which dies when the response is sent. So if 1,000 requests come in simultaneously, you have 1,000 processes handling them concurrently. supervision tree for a Phoenix app looks roughly like application, top supervisor, repo, endpoint, bunch of processes underneath it. I don't have to define that because it's just part of. How does something use itself as a general purpose Elixir, not specific to the application. It's a macro that calls using on the given mod. Use itself as general purpose Elixir, not specific to application. Equivalent to require application.using, which injects default callback implementation into your module. Define application view mod. Happy groups mod application that mod key is the critical piece. When Beam starts your application, OTP reads the config and calls my application.start. That's where your supervision tree gets built. My module, my app application, do use application. You run mix. Mix reads this, sees mod, calls start. The supervision tree is now running. Without the mod config, nothing happens. So it's sitting there, even though. Okay, register, rate limiter.check. I have this type of thing in my login code. And rate limiter looks like this. My question is the rate limiter always using the same process? The answer is nuanced. There are actually two different things happening in different processes. GenServer process only does two things: creates the ETS table and init, runs the periodic cleanup. The check never calls call or cap. It's a plain function that hits the ETS table directly, so it runs in whatever process calls it. Typically the request process. This works because you created a table with public access, meaning any process can read right to it. What is ETS table? "100 requests come in simultaneously. Check/3 runs in 100 different processes, all accessing the same ETS table concurrently. Valid design choice. Running every rate limiting decision through the GenServer with call would make it a bottleneck. There's a race condition. 2 requests for the same key can interleave like this. Process A read entries times 4. Process B reads entries. A writes. Both get through and B overwrites A's timestamp. The rate limiter, this is probably fine. Might let a couple extra requests slip through the boundary, which is acceptable for login throttling, but worth being aware. You could use ets.update counter with an atomic counter. Ever needed exact provision, you could use ets.update. Instead of storing a list of timestamps, store a simple count and use ets.update. Fourth argument is the default tuple. Increment the second element by 1 and return the new value. What happens in 1 atomics? Trade-off is you lose the rolling window. You're bucketing time in the fixed windows instead, dividing the current time by the window size. Move check to a call. GenServer approach keeps your exact rolling window logic unchanged, but creates a single point of serialization. Every request across your application funnels through one process for rate checks. Under low traffic, that's fine. Under high traffic, that's bottleneck. Rate limiter specifically, the atomic counter is usually the better choice. You're already accepting approximate behavior by its nature. A fixed window bucket is usually good enough. Counts. Accounts, context, handles, user registration method. Alias. Tasks. Where is it actually? I don't see where this is used. I guess alias means it's used. Accounts? Alias. This alias. Let's use part of that module name as shorthand. After that, you can write user. Yeah, accounts.getUser. Not really a fan of aliases. Makes it a lot harder to track what's being used where. HappyGroupServer.web accounts dot register user and click over. You want to install the ElixirLS. Elixir support. Fun. Common fixes.
I explained that Elixir and Erlang are installed, but the IDE isn't seeing them because its path doesn't include the proto-shim directories. I suggested adding those shim paths to V's code settings, JSON or launching the IDE from a terminal so it inherits the correct environment, and I offered to check your V's code settings or help configure this.
Launch IDE. Go ahead and whatever. Let's see.
Permission requested. Command. Permission requested. Permission requested. Command. Permission requested. Command. Permission requested. Command to list proto-shim's directory. Permission requested. Reads. Permission requested. Read. Permission requested. Permission requested.
Jesus.
Permission requested. Permission
I gotta
requested.
turn this off.
Command.
Down the root cause. Proto path is configured in key0 file is sourced from ZSC. Only load for interactive shells. Launches with non-interactive. Proto in path. Elixir can't be found.
so. No, 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 no.
Did we update anything in setup?
I explained that the setup sh file is a one-time user-level configuration located at ~config/ElixirLS/setup sh and is only relevant for developers working on the Elixir project, so it doesn't need to be documented now. I added that if ElixirLS setup becomes a recurring issue for other developers, we could incorporate it into the setup environment sh script to handle it automatically. Permission requested. Edit setup environment. sh file. I read the setup environment script, edited it to add the ElixirLS configuration into the environment configuration section, and then read the file again to verify the change.
Elixir. Nice, now the developers.
Permission requested. Edit settings. JSON file in the Kiwi project. I read the Visual Studio Code settings file and edited it to add an ElixirLS project directory pointing to app/happygroup/server while preserving the format on save setting. Permission requested. Edit settings. JSON file in the Kiwi project.
But I would have to open up separate screen windows.
explain the trade-offs between using a multi-root workspace, which gives both Elixir projects ElixirLS support in one window, but changes the sidebar layout and may affect some extensions, versus keeping a single project dire and opening the other project in a separate window or manually switching it, which can be annoying. Which Elixir project do you spend more time in Galinks or Happy Groups?
Using workspace file to define projects, Elixir will limit all VS Code features to the project. Find a file with quick open with VS Code has a handy quick open feature. Using it, I can enter partial paths to the file. Multi-workspace root, and there are many files in the same project name located. Lottery, but with multiple code projects. Optimal tooling support. Go ahead and
Permission requested. Edit settings, JSON file. I read the V's code settings and project files, removed the Elixir project directory setting from the settings JSON, and then created a new workspace file named KiwiCode Workspace that includes the root folder and the Golinks and HappyGroups server projects.
Use it, open the workspace file in VS. Yeah, that works now. The multi-root, or just give Elixir TypeScript, Python, and everything else already works fine. It's their tool. Okay, so that's working. I'm gonna review this code. Stage changes. Here we go.
Permission requested. Command to format workspace file with prettier. formatted the Kiwi code workspace file with Prettier using both npx and pnpm commands. Then read the updated file to confirm the changes. I noted that the file needs to be restaged before I can commit it. Committed as 690 DFE3. All pre-commit checks passed.
That. What are you doing, pup? What are you doing? Let's see. Kiwi dot. clear. We fix these. We committed some changes. We have smashed. Involving our user setup. We want to do those changes, and then I'll
I read the router Elixir and user socket Elixir files, inspected recent Git history, and searched for missing absinthe and auth references. Then edited the router Elixir to drop the GraphQL pipeline, absinthe context plug, and related forwards while keeping the API pipeline, and simplified the user socket Elixir by removing the user token alias and verification logic, which eliminated all 5 dialyzer errors.
What's going on here? Let's start breaking this down. Not endpoints. Students use origins, be part of our. Where's it? Dev.
I edited the dev Elixir script, prod Elixir script, test Elixir script, and the endpoint Elixir file to move the core's origins into per environment configuration, and replace the hard-coded list with a call to application compilenv for the core's origins key. This separates production, development, and test origins, and ensures a compile time error if the configuration is missing.
We should define the explicit routes and both dev and prod specify there. No, fuck. Tagging the wrong thing. No, .ex.
replace the generic dev routes flag with an explicit enable graphical config in the router, updated the development configuration to set enable graphical to true, and updated the production configuration to set enable graphical to false. So both environments now explicitly control whether GraphIQL is enabled. I updated the router file to replace the dev routes check with an explicit enable live dashboard flag and added the necessary imports. Then I modified the development configuration to set enable live dashboard and enable mailbox preview to true, and the production configuration to set both flags to false. I also explained that Golinks is a server-rendered live view application and does not use a Corsica CORS setup.
Oh. Heavy. What do I need to check here? Specific. Yeah, some questions. What is the difference between Happy Group Server and Happy Groups Server Web? What are these? Server is the business logic. Domain layer, context schema, database queries, application logic that has nothing to do with HTTP WebSockets. The interface layer, everything that deals with how requests come in and responses go out. The endpoint, router, controllers, channel plugs, GraphQL schema resolvers, and telemetry. This layer calls into ElixirServer for actual business logic. There's no requirement for this, right? This is just standard organization. Dimension. Do a bath, Miss Pup. Do a bath. Alright, Miss Pup. Let's give you a bath. We'll come back to this later. Should I keep the stream on? It's so annoying how you can't pause a stream and resume it. It's such an annoying function. Like, why not implement that? It's just I'm gonna be gone for like an hour and a half. Yeah, I'm gonna turn the stream off. I might turn it back on later at like 6 if I do like 6 to 10 maybe. We'll see.